Hey, do me a favor. If you find this helpful, please click like and subscribe. Thanks. Goal with all the labs that I've ever taken has always been to get out of lab, to go in and finish as quickly as I can and get out. And with the labs that involve programming, like the Verilog, or later on when y'all take microprocessors, it's often possible to do almost all of it at home, and then you come in and you're just like, if you get it done, and then you can have it done and go in and check out and leave. So I don't know if I end up spending more time getting ready, to do it ahead of time than I actually do in lab, but I like getting done. And so I'm going to show you all some things that you can use. If you actually install Vivado, that's ideal, but it's a huge program. If you have a laptop, you may not have a ton of disk space. It takes forever to download, and it doesn't run on a Mac. And so that may not be an option for you. Now, one thing I do recommend that is free and is good for any kind of programming is this program called Notepad++. And with Notepad++, and this is what coders everywhere use this. This is like not, this is something that's well known. And what it will do for you is it will work with all kinds of different languages. So it doesn't have a compiler. You can't run anything with this. But if you tell it when you start, so I say here's Notepad++. Let me see what all it probably has versions. I know it has Mac and Windows, probably in Linux. Let's see if it has iOS as well. Let's see. Oh, it knows I'm on Windows, so it's not. Okay, ARM64. Okay, so you'll have it that'll run on some different kinds of processors. Anyway, everybody, they'll all have something that it'll run on. So when you start a new file, you'll tell it what language you want to use. You can see all the different languages that it knows. So I can tell it I want to use Verilog, and then it will know when I've got a keyword. And then it'll tell me if I make a syntax error. I thought it did. Maybe not. Okay, so for instance, I can't remember for any particular language how for loops work. Okay, so I type I. It wants me to do input because I forgot to define I as an integer. For I equals 1 semicolon, I less than 3 semicolon, I equals I plus 1. I have no idea. That can't be right. That can't be right. Okay, I thought it would give me more clue there on what the syntax would be. But it also, once you start indenting, it'll continue indenting for you. Anyway, it just makes it really nice. And it does other things that I'm not aware of because I didn't find out about this until like near the end of the semester, last semester, but the people who were using it found it very helpful. Okay, so I don't know much about it except that it is a great editor that a lot of people like to use. Okay, so there's that. The other thing that you can do is there is a place where you can run your Verilog without having to go to the lab, and it's this place called EDA Playground. And in order to have full access to everything that's on here, you have to use your LSU ID to make an account. And so I have the instructions that I made up several semesters ago that I recommend for doing this. So, and here's how I use it. So first of all, you need to have an account. You'll want to make sure that you use your full LSU email address because otherwise you won't have access to the compilers that you need. And then I find the easiest thing to do when I get here is to do an example, to come up with to choose one of the examples, and I just use the top example as a D flip-flop. And actually, why don't y'all all go ahead and go here, and we're going to see how this works. So if you can open up a browser and go to edaplayground.com. Log out. And then what I do whenever I want to make some new code, under the examples, I go to Verilog and System Verilog, and I just choose D flip-flop. And that has all the settings over here the way I need them to be. And so that way I don't have to remember what the settings are every time. And then I can just delete these and type my own stuff in and then save it. Now you probably would not be able to save it like so I can copy this and then I can save it with a new name. And then save it. And then I can put my own stuff in here. So, and then this way, like, I'll show you what it looks like when we run it. This is a D flip-flop. And it has the test bench, which we're going to talk about later, had it display some various different things. And so it's showing what it did right here. So it's saying it reset the flip-flop, and then it gave it values for X, Q, and QB, and then it said what the new one was, and it's displaying it right there. Okay. So now let's talk about the lab that y'all are going to do. which is somewhere right here. Okay, so the first thing that y'all are going to do is to program the basis board following the steps in the handout using Vivado to program the Basis 3 board. How much of this did y'all do last semester?
That was like most. I think I thought the third or fourth lab in Geologic 1, but the rest was just fair long.
Okay, so y'all did a lot of this.
Probably like the last half of labs, I'd say.
Okay.
The last 4 or 5. But
all right.
I think we did like two labs on. Just 2 or 3.
I remember one that took a long time.
Yeah.
Okay.
One took a long time.
So the handout here is quite valuable, and until you get used to what the steps are, you will find this a great guide using Vivado to program the Basis 3 board for Lab 4. So this one, you can use this one for your later labs too, and I will demo how it's going to work. Okay, so you'll start Vivado. Do I have it started? If you're looking for it, it's under Xilinx. And there are some things that it does so many things, and I've just like figured out what works and what doesn't work, and I don't always know why. And you'll always go to create a project, and you'll call it whatever you're going to call it. And it'll be an RTL project. And I've done this so many times, I know the basis board, you go to Artix 7, the package is CPG 236, the speed is -1, and it's this third one right here. Now, if you don't remember all of that, that is all right here in this handout, and it'll tell you. Let me choose this. And next, and finish. And then your main Verilog is going to be your design source. So you would, this is how I add my new file. And there's different ways to do it. I click on design source and I click on the plus. And I add and create design sources and create file. And I'll give it a name. I'll call mine Lab 4 main. Okay. And finish. And you can put inputs and outputs right here. I typically don't, and I'll tell you why in a minute. I'll come to yes. And then that's new. Wow. Huh, I made Vivado unstable. Okay. I'll come here under design sources, and if I had given it some inputs and outputs, it would have gone ahead and put them in, which might be handy, but I have found that it is easier to debug for me when I do my inputs and outputs like this. So there are different ways to do your inputs and outputs. I like listing them all up here and then having input and output rather than having them. You can do them like this. You can put them all inside the parentheses, or this is like the most compact, and it's probably like the most elegant way to do it, but I like to do it like this. So yeah. Copy all these, and this is what you are going to do, is you're going to have this, but notice if I just cut and paste it, it's putting the line numbers in. So, and it really is so much better if you actually make your indents correct. It makes it so much easier to find mistakes. I'm missing some stuff here. So if you just cut and paste like I do, it will sometimes have errors. Like for instance, this right here, that symbol doesn't copy and paste correctly from Acrobat, and you can have like forever finding out what the mistake is. Okay, so I now have my module in there. And then what do y'all know about constraints?
Well, it's pretty much where I would say that's where like most of the hard work is. It's like that's how
That will change.
that will change.
That will change. The constraints is the easy part.
Oh, that was the hard part last time.
Yeah, no. I mean, okay, so but tell me what you do for the constraints.
Well, the constraints is pretty much like setting up the pins, and also like if like the one lab we have where we have to do like the flipping the switches and to show like that what is it, like the display, like getting it to display on that display screen.
Yeah.
All that stuff on the constraints.
So the that is going that's going to end up being pretty pretty second nature, and hopefully he has here a template file. Okay, so I always do my constraints like it says up here. There is a generic template from here that is really useful. So it has everything that you would use. And then I'll go to my constraints. And new constraint, add or create constraints. Create file, lab 4 constraints. Yes, I want to convert those. Don't need that. Course hero? Wonder where that came from. That was odd. Okay, so here, once you have all the constraints, if you know which ones, what you want to use, I tended to be super lazy and like I would name my variables the same that the things already were in the constraints. So like if I needed to use the 7-segment display, did y'all use the 7-segment display to make like the letters?
Yeah.
And so I would just call that variable seg, so I wouldn't have to rename it here in the constraints. And so here my switches are 0, 1, 2, 3. So if I wanted to use, on mine, I have, the inputs are A, B, and C. So I will just uncomment the first 3. And I will rename those A, B. Now I will tell you, mistakes are often in the constraints. That when it just doesn't compile right, it's often a problem with the constraints. So those are now A, B, and C, and those are pins 17, V17, V16, and W16, and you should have here is a picture of it, and so you can look at it and see that those are these last 3 switches right here. So if you wanted the first 3, it'd be over here. So the way the template is designed is it's going from right to left. And then I have 2 outputs, D and E. So I'll have 2 LEDs. So I'll go to my first LEDs. And I'll uncomment them. And then most of the students that I worked with have worked with in the past. See, I have too many bad typos in there. Would delete all of the other stuff. I keep it just because it's not hurting anything. So there. So now my constraints are all set up. And then what is probably new is the test bench. Test bench is new, right? You're looking.
I've never used this before.
You've never used Vivado before? You are a transfer student, right? Okay. So, is that new to you?
Well, it's just Verilog.
Okay, so Verilog, you know
I know
Verilog.
Verilog,
Okay, then all this did right here was just say, all I did was say that I am mapping my variables A, B, and C, which are my inputs, to these switches. So now this is A, this is B, this is C. So if I want A to be 1, I'll flip that up, and 1 to be 0, I'll flip that down. And I mapped my outputs D and E to U16 and E19, and those are, no, they're right above it. U16, so it's just a little bitty light right here, U16 and E19. And so those will light up when they're in outputs. When they're 1, they'll light, and when they're 0, they won't light. And so it's a whole lot of stuff that you don't need to you don't have to understand. I don't know what it is, but I do know how to do this. I mean, I get the template file and I now know that A goes to V17 and I can find V17 on here, and I'm set. Okay. Now what the test bench does, and you have to do this in order to make it run on the board. But if you don't have the board, then how can you test your code outside of the lab? Or how can you test it? It takes a while for it to compile. I don't know why it takes so long for it to compile, but it takes a while for it to compile and then to load onto the board. But there's a way that you can test it using a test bench. And so I'm going to go to Simulation Sources and Plus, and I'm going to make a new simulation source, and I am going to call it, create file, I'll call it Test Bench Lab 4. OK, and finish, and OK. And this also will seem kind of mysterious, but you'll get used to how it works, and then you'll be able to make it work. One thing you want to make sure is over here where this is what I just made, if I right click on it, I want set as top to be grayed out, and it's not grayed out, which is unusual. So let me see what I need to do for that. Right click set it, otherwise click it. Okay. Okay. There, now it is. Okay. So I'm going to use the code that we have here, and we're going to walk through it and see how it works. I wish the line numbers were not here. Oh wait, I did this earlier. Hold on. I'm cheating. Okay, so let's take a look at this, and you'll see how to set it up. So you're going to give it a name just like you would always give it any module a name. So this one was pre-named testbench_main. Then whatever was an input in your main module, you declare as reg. So in my main module, A, B, and C were inputs. You make those reg. Whatever were outputs in your main module, you make those wires. Anything else you don't need to put in here. So anything that you had as a wire or anything like that, you don't need to have in there. Then this next part is important, that this name right here has to be the same as the name of your module. So I called my module very creatively, I called my module main. And so that's why this is main right here. This main is not a keyword. This is whatever the name of your module is. This is a variable name, but it's really common to use UUT, unit under test. And then you put all your variables right there. Now, if you'll see two different ways to do this. Here I have them now these are capital letters, but they're very carefully in the same order as they are right here. If I have them in the same order, then I don't have to worry about using this dot and parentheses notation, but you will often see that notation. Let me show it to you here. So if you look over at this example right here, the .clc and then clock in parentheses, what this is saying is the clock, whatever I call clock over here, should refer to clock over on my main program. And so that way you don't have to worry about having the same order. And if you're going to be doing a lot of editing, it's probably a good idea to use this kind of dot notation, and then that way the order doesn't matter. Okay, then you're going to have an initialization part. So you'll have initial, and you'll have a begin and an end to say you're initializing your simulation. Anytime you want to display something in your console, you use the $ and display, and then the open parentheses and then things that are in quotations just display right on the screen. And so it's going to display test bench start, and it'll display ABC, and this is just plain text. These are not variable names, this is just text it's going to put out here. And then because you don't have the switches to switch, you have to say you're giving it different values of A, B, and C to try out and see what happens. Here we're going to start by saying ABC equals 0. We're going to do them all at once, and that makes it easy. So concatenate A, B, and C and make them equal to 0. Doesn't mean they have to be concatenated later. You can use them concatenated, but you don't have to. Okay. And then you end your initialization. Then you're going to have a block that's going to actually run, and it's an always block, and it's just always. And then you'll have a begin and an end for your always block. The hashtag in the 10 is telling it to wait for 10 nanoseconds, so it just gives it a little bit of a pause time. And then what did y'all do for your programming language? C? C++?
I'm in C++, yeah.
Okay, and same for you? Okay. So this won't be that unfamiliar to you. So this is telling it to display the values of A, B, C, D, and E. So the %D is a placeholder, and it's going to fill this in with the first variable in the list afterwards. So this is all in quotation marks, and it's saying to display the decimal value. If you wanted to display the binary value, you'd put %B. And then it says if ABC equals quotation B111, so the B is saying binary. So if A, B, and C have gotten to 111, then you would want it at that point to say you're done, and it display test bench end and finish. So that's in a begin and end. So these should really be. I'm gonna fix this. How do y'all indent your begins and ends? Do you indent the begins and ends, or do you
I
have
would
them lined
probably,
up?
since the begins, I guess another something, I would probably indent begin and then indent display and display.
Yeah, I've gotten kind of lazy on that.
Not even good.
And then a lot of people do this. They put the begin. Ooh, it doesn't like the. Oh, okay, there we go. They put the begin on the line before.
Yeah, that makes sense.
Okay, so else, if we're not at 1, 1, 1, we're going to add 1 to A, B, and C. So A, B, and C are going to go through 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, so just like a truth table, and end module. So it should display the values for A, B, C, D, and E for all the values for 0, 0, 0 through 1, 1, 1. Now, we didn't talk about what main did. We said, let's look at it. D is A and B. Okay? And then we have an always block. If A is 1, E is B in the exclusive OR of C, else E equals B or C. Okay. All right, so now that I have all that done, I can go to run simulation and run behavioral simulation. I'll save it first. And down here, because I told it to first display test bench start and ABC vertical line DE, and then I told it to display this. And so those are the actual values of A, B, C, D, and E. And so I can now look at them and see, is this what I'm expecting? Do you remember what D was? It was A and B. So D should only get to be 1 here, and there it is. And then if A was 1, E was B exclusive or C, or B. That is exclusive or, right?
I can't remember.
Yeah. So when A was 1, B exclusive or C. That seems to work. Okay. So so that's how the test bench works. And if I go here, this is not correct. So here's just this online thing that I put the same code in, and I can run it, and I can do this without having to download Vivado. Yeah, you didn't write it down before, did you? Yeah, you didn't think
forgot the name.
you didn't think you'd want it. Yeah.
It's kind of like online GDB, which is what I use for coding, because I tried like a bunch of different software and I just wouldn't compile, so I was like, I'll just use online GDB.
Does it do Verilog?
No.
Oh, okay.
It only does like C++, C, I think Java maybe.
Okay, this is the only one I've found that does
That's really
Verilog.
useful.
As soon as you said what it did, I bookmarked it.
Oh, okay.
I'm gonna have to use that.
Now, with the first semester I used this, it's had some downtime, and it was kind of frustrating because you'd go to run something, and it would take forever and ever and ever, and then it would say, you ran out of time. And I never knew if it was me.
What?
Yeah, it's like, you've used up all the time you can use. I never knew if it was me, if I had like a loop, an infinite loop or something. But lately it's been pretty good. But you can't test your constraints here, but you can definitely test your logic. And you can also find there are other examples here, so you can see what other people have done. Let me save this.
So the test bench is pretty much just like a virtualization of like what it would be.
It's a simulation. It's a simulation. So like, oh, maybe there aren't very many good things in here. I thought I found stuff in here, but maybe not. Okay. And let's see what else was in your lab. So Notepad, I do like Notepad++. So that you can write your code in that and then save it and then bring it to the lab, and you'll have it ready to go. And oh, okay, yeah. So part 2. So that you'll have to do what I'm already done. If I had the board, I could program it. Since you've never done this before, let me just show you what's involved with that step. So one thing you'll do, you should do this before you try to compile it, is you open elaborated design. And what this does, this is where Verilog does its thing, which is you want it to behave like this. This is the hardware that it corresponds to, and this is the hardware that I'm going to simulate. So when you do this, if it doesn't look like anything like you think it should, then you've made a mistake. Usually, if your code is good, you say, "Oh, that's exactly what I wanted." An exclusive OR and an OR and a multiplexer and an and okay, there we go. That's the hardware that it's simulating. That's usually something you have to turn in your lab report. And then what you're going to do, and this is not going to work because I don't have the Basis board plugged in, although I do have one that I put in my email that y'all are welcome to come to my office and use it if you want to. To generate the bit stream that you're going to load onto the Basis board. And for some reason, it takes forever to do that. And then you'll run it, and then you'll have your board, and you'll flip the switches, and look, it works, and you show the lab instructor. And okay, but the other part of the lab is that, okay, so the first part is exactly what we just did, doing that exact lab. And then the second one is to create a full adder. And so for the full adder, you've got this truth table here. So what you have to do is come up with the Verilog for this, and it's given to you right here, really. You've got the Verilog for that, and then the constraint file, test bench code, and simulate your design and program the board. So, and this is theoretically what you would be doing in lab. If it were me, I would do this at home and then go in, and then I'd already have it done, and I would get out of there. So what you'll have is, instead of this code right here, you would have the code that would just do this. So it's going to be very simple. You're just going to assign would you do it in an always block? I probably would. So I would probably do it in an always block, and then put these in there, and then in your constraint file, sum is going to be one LED and C out is going to be another LED. A and B are going to be inputs. CN is going to be a wire, because CN is going to be something that you'll make from A and B. And your test bench, your test bench is going to be simpler, because you only have two inputs. You only have A and B. You don't have A, B, and C. And so your test bench, the way it would change is you would have just A and B, and your output sum and C out. You might want to also have, you might want it to display C in.
Should we put C in before the bar line? Because it had to be in the table.
Actually, if you remember, I probably would not, because CN is going to be a wire in your main. So it's not either an input or an output. So it's, if you want to display it in your test bench, you'll have to make it also an output.
Okay.
So you could, and you might want to do that for debugging purposes. And that's what test benches are good for, is for debugging. So yeah. And then if you just are having, you would not put A, B, you would not put C in here,
You just put it in B.
just A and B, right?
And then you get rid of the other percent B.
Right,
The third one, yeah.
right.
Okay.
And probably you'll want here,
It'd be-
I like B, I mean, I don't know, maybe that's why it was D. You know, it's the same, you know, I don't know why in this one they had D instead of B. I would do B. But so, and that will be your lab.
So you would recommend doing for like the circuit gives us, you recommend doing it always? Put that in the always block? Like the sum equals A exclusive, B exclusive.
Let's see. Yeah. Except for the following, let's see. Here's probably how I would do it. Oh, we do need Cin to be an input, because, yeah, we do need Cin to be an input. Yep. Because the Cin would be coming from another, it would be the C out of a different module.
Gotcha.
Did you not put them in the same spot?
I can. I was thinking that I keep getting confused about what Cin is. Cin is not an output. I keep thinking Cin, the reason I was going to do two of them is I was thinking that the sum produced Cin and then you were using it in the other one, but you're not. So,
Gotcha.
yeah.
I was forget to put B in.
Well, I wasn't going to need it when I just had one line. A, B, C in, C out, sum. I really shouldn't be using the same variables here, but I do.
So A in the test bench, A and B would also count as a reg. So you do reg A, B, and C. Or would you just do reg C?
Anything that was an input
Declaring
is
okay,
declared a
I see.
reg.